Good morning, Overall Middle School students. This is Mr. Woolley again, and we are working with Lesson 4 today, efficiently adding integers and other rational numbers. So, if you want to represent the sum of 3 plus 5 using arrows on the number line, our first arrow starts at 0, moves right 3, and move up a little bit for our second arrow, move right 5, takes us to an 8. And the arrow represents the 3 is 3 units long, it's moved right. The 5 is 5 units long, and it moves right. And the sum is 8. And that, if you're going to represent that sum using an arrow, well, it'd be 8 units long, and it would be pointing to the right. The length of that arrow and the absolute value of that number are the same. So however long how long the arrow is, that's the absolute value of that particular number. Do you think that adding two positive numbers will always give you a greater positive number? Yes, because the absolute values of both numbers are positive, which means you continue to move further right in the number line. So anytime you add positive numbers, you move to the right. All right, next up, represent the sum of -3 and -5. You can use arrows that represent -3 and -5. So start at 0, and you move left 3 places, go up just a tiny bit, start a new arrow, move left 5 spaces, now you're at -8. 3 units long for the arrow that represents -3, and you've moved to the left. 5 units long for the arrow that represents -5, and it's to the left, and your sum is -8. And how long will the arrow be? It's 8 units long, and it points left. And do you think that adding two negative numbers will always give you a smaller negative number? Yes, absolutely. Because if you move left with the first number, you move left again with the second number, you keep resulting in a smaller and smaller negative number. What do both examples have in common? Well, both examples added numbers that had the same sign. And you add the absolute value of both numbers and just keep the sign. So if you are adding positive numbers, you just add the numbers and keep it positive. If you're adding negative numbers, add the numbers together and just keep them negative. So the rule, add rational numbers with the same sign by adding the absolute values and using that common sign. So you just keep the sign. All right, now they give us a set of problems here. Decide whether the sum will be positive or negative without actually calculating the sum. Well, we can do that and actually get the real answer. So you can kind of look at our examples here. I'm not going to read through all these. You guys can kind of see these. And there you go. You can pause it if you want to look at those closer. All right, now I get to some real problems here. 15 plus 7 is 22. These are both negative, so I know it's a negative answer. 4 and 16 make 20. These are both negative, so I know I got a negative answer. 18 and 64 make 82. These are both negative, them adding together, so I know I got a negative answer. 205 and 123 make -328. Now, how do we add opposite signs, though? Like 5 plus -3. Well, the first arrow would be 5, move right 5, move up a tiny bit, and you move left 3, leaves you at 2. So how long is the arrow that represents the 5? 5 units to the right, and -3 is 3 units to the left. So which arrow is longer? The 5 arrow was longer than the -3 arrow. So what is that sum? Well, 5 plus -3 left us at the +2. So an arrow of that sum, if you're talking about just the answer, would be 2 units long, and it points right. How about 4 plus -7? Well, start my arrow at 0, move right 4, go up a tiny bit, and now go left 7, takes me to a -3. All right, so we can use the number lines for those. So our rule here, add rational numbers with opposite signs by subtracting the absolute values and using the sign of the number with the greater absolute value. What's that mean? Well, we'll take a look at what that means with some actual examples now. In this scenario, kind of like before, you can determine whether the answer is positive or negative, because they want you to circle the sum first, or circle the greater absolute value first, and then determine positive or negative, then get the answer. If I'm trying to add a -1 and a +2, well, there's more positives than negatives. There's 2 of those, only 1 of these. So it's going to be a positive answer. Let's take your winning number, I guess you could say, take away the losing number. So 2 minus 1 gives you just a 1, so it'd be a positive 1. Here, the greater value is the negative number. There's 9 of those compared to 5 of those. So I know my answer is going to be negative. All right, and then just take your winning number, the 9, take away the losing number, which is 5, 4. So negative 4. Remember, you already made the decision if it was going to be negative or not. So negative 4. Here, once again, you have a negative 6 and a positive 3. There's more negatives than positives, so you know your answer is going to be negative. So just take your winning number, the 6, minus the 3, and you get negative 3. It's negative because we already decided that. Over here in part 4, there's 11 negatives, only 1 positive. There's more negatives than positives, so our answer is going to be negative. And then just take 11 minus 1, and we get 10. So negative 10. Got a couple more examples for you down here. Find the sum. You got a negative 10 plus 7. Well, that would give you a negative 3. 8 plus negative 16, negative 8. Negative 12 plus a positive 65, positive 53. 105 plus negative 126 gives you a negative 21. All right. And what do we do about this kind of scenario? Applying integer addition rules to rational numbers. What do you do when you have to add like a mixed number and stuff like that, or fractional amounts in? Well, we can still treat it just like normal. The absolute values of each number is you have 6 positives and you have 2 1/4 negatives. And you subtract them. All right, there's more positives than there are negatives, so we know it's going to be a positive answer. So 6 minus 2 1/4, we had to borrow from the 5 and make it 4/4, that way we could take away the fraction. 4/4 minus 1/4 gives us 3/4, and 5 minus 2 is 3. So it's a positive 3/4. The sum of negative 18 and a positive 7 was more negatives than positives, so I know I got a negative answer. Just take your winning number, the 18 minus the 7, gives you 11. And remember, because it's going to be a negative answer, it's negative 11. B, if the temperature outside was 73 degrees at 5 p.m., but it fell 19 degrees by 10 p.m., what's the temperature at 10 p.m.? Well, it already starts out at 73, and then it drops 19 degrees. So it's a negative 19 situation. You have more negatives than positives. We're still staying in the positive temperatures. So take 73 minus 19, and we get 54. So you can look at the diagram below. We start our first arrow at a negative 10, and then we add 3.5 because I'm coming back to the right. Negative 10 plus 3.5. How would you do that mathematically? Well, if I was going to do that, I have more negatives than positives, so I know it's going to be a negative answer, so I already put that down over here. Then just take your winning number, the 10, minus the losing number, 3.5. 10 minus 3.5, well, we'll borrow, drop that down to a 9, and let's create that little fraction of 2 over 2. Now I can take away 1/2. So 2 halves minus 1/2 gives you 1/2. 9 minus 3 gives you 6. But remember, we decided it's going to be negative, so it's negative 6.5. All right, let's take a look here at our problem set. Okay, if I have 4 plus 17, that's just going to be 21, of course. If I have a negative 6 and a negative 12, they're both negatives, so I just add them together and stick a negative sign in front of it, negative 18. For C, I have 2.2 plus negative 3.7. Well, I know my answer is going to be negative because there's more of those. And just take 3.7 minus 2.2, and you get 1.5. But remember, we decided it was going to be negative, so it's negative 1.5. A negative 3 and a negative 5 make negative 8, plus a positive 8 just give you 0. All right? And I'm going to skip over part E here for just a second, just due to time constraints here. If you want to take a look at that and solve through some of the work I did, you can do that also. We're going to move on to some other problems. Which of these story problems describes the sum 19 plus negative 12? Well, our first scenario does, because he gets paid $19 and he spends $12. So that describes that situation. Jared owed his brother $19, so that'd be negative, and his dad gave him $12. Well, that'd be a negative 19 and a positive 12, which doesn't match up with what I'm doing up here. Jared's grandmother gave him $19 for his birthday. He bought $8 worth of candy and spent another $4. Well, that means he spent $12, so he's gained 19 and spent 12. Yes, that will apply to that scenario that we show up top there. So the first and third ones are your good options. All right, use the diagram below to complete each part. Label each arrow. Well, we have a 5. And then we move left 3, so it's a negative 3. And then from there, we move left 7, so it's a negative 7. So how long is each arrow? Well, the first one's 5 to the right. Second one, 3 to the left. Third one, 7 to the left. So what's that equation? 5 plus negative 3 plus negative 7 equals negative 5. You can double check just due to where your final arrow ended too. It's at negative 5. All right, our last problem for the day here. Jennifer and Katie were playing the integer game in class. Their hands are represented below. What's the value of each of their hands? Well, a 5 and a negative 8. There's more negatives than positives, so you know it's a negative answer. And 8 minus 5 is 3, so negative 3 for Jennifer. Katie, more negatives than positives, so we know it's a negative answer. 9 minus 7 is 2, leaves us with negative 2. If Jennifer drew 2 more cards, is it possible for the value of her hand not to change? Explain why or why not. Well, yeah, if she drew 2 more cards, it could just keep her value at a negative 3 because maybe she gets like a 1 and negative 1, which total up to 0, which won't affect her score at all. She'd still stay at a negative 3. If Katie wanted to win the game by getting a score of 0, what would she need? Well, Katie's at a negative 2 right now, so she'd need a positive 2, because a negative 2 and a positive 2 are going to give her 0. If Jennifer drew a negative 2, negative 1, and negative 2, what would her new score be? Well, Jennifer already had a 5 and a negative 8, so remember, she was already at a negative 3 for her balance. And then if you have a negative 1, now that takes her to a negative 4, and then a negative 2, now that takes her to a negative 6. All right, well, thanks for watching. Go ahead and give the practice a try in Schoology, and good luck.